Hey, how's it going, guys? So here we are back again, doing Open-FDD devlogs here, and it'll still kind of like work its way into the Python BACnet stacks playground. Sorry for being a little bit absent here, but I've done a ton of work for the Open-FDD project, um, and I think this will all kind of like lead into maybe studying some fault detection rules here in the near future too. So this is after kind of maybe experimenting a little bit with some of these protocols, some of the BACnet stack and Rust is another thing I want to get into playing around with a little bit too. I think it would be neat to get into doing a little bit with the Python and Python fault detection rules with Apache Arrow. I just thought of something. So, um, okay, so if I go to GitHub Gist, and I was just shoot, this is the wrong one. I was just doing like a little bit of research for basically how to get more familiar with Apache Arrow and data fusion and data engineering. So this is like something that the Open-FDD project learns, looks at pretty heavily under the hood. So I might do a little bit. This looks kind of interesting, but it's basically it's a data scientist course for how to use Apache Arrow and PyArrow under the hood. Um, I'm kind of thinking about maybe doing this. I have some downtime, so this should actually be like a might fit in really nice to doing fault detection with Open-FDD. So this is coming. So like maybe I'll do this next week or something. I want to try and get more doing things faster. So, but yeah, it looks like they have like a pro month plan. I've been really kind of interested in data engineering, just like very generic data engineering. So that's kind of like the way of like extracting out of buildings, like how to get in at least in smart building IoT world. It's this seems kind of like an interesting codify the C basics. It's basically how to get data out of buildings. It can be anything really in the IoT world. Let's just see if they got anything for data engineering, data processing, and feature engineering. So that's more like machine learning. Um, Introduction with data engineering with Azure. Um, Nothing's really jumping out at me though. So chess game analytics, pretty cool. So I don't know. Maybe this should be something to play around with. So Apache Arrow, PyArrow. That is what Open-FDD version 3 is really leveraging under the hood. Um, and it's next on the to-do list. But first, let's knock a little bit out of the way. So Python BACnet stacks playground. We'll get back into this as sooner or later. I think I just want to jump right into the Rust. I have an idea of, first of all, Open-FDD over time. We will convert Python code to Rust. So maybe we can even document some of that. And like some of it is more like core computer systems level. There's a web app that runs behind the scenes. Data gets crunched. There's a Rust BACnet stack, so the Python code will get slowly converted to Rust. But there'll still always be a Python API. So like even the Rusty BACnet stack, there's still a Python API, but it's still 96% Rust under the hood, which is a much faster, efficient coding language to use. Python is just a scripting language, and Rust is actually a compiled systems programming language, which is much faster and efficient than having something completely written in Python. But Python is still nice just for an API. Um, like this, you can still, maybe this would be fun to play around with too. It looks a lot like Backpipes 3. But under the hood, instantly, pop the hood on the car and it's all Rust under the hood, which is much more fast and efficient. So like this is coming. But first, I still wanted to play around a little bit about more about this Bask stream. So this is written in Java. So this is running in the I contributed some Python tools to it. Um, this is running in Java, and it's for the Niagara framework, which is all Java. So pretty cool. It's Niagara 4 runtime modules, authenticated WebSockets API. So this is really neat. I think I talked about this in the last video, is that the person that made this works for a graphics company. So this uh, really data rich. You can pull lots of data at once. WebSockets is kind of a cool tool to use for that, which I'm still kind of learning. Um, so like WebSockets, I think like we talked a little bit about the past, which we'll have to get into more some examples here. Like if we just use plain old RESTful API, there's like a connection and they play ping pong, and then the connections close, open, close, open, close, open every time the ping pong ball is hit back and forth. But WebSockets, to my knowledge, there's just a constant connection, TCP based. So data is just like streaming back and forth. Um, so it's supposed to work really good for subscribing to data. I know it's not like BACnet, which is a UDP language, but um, yeah, I think it's basically the in WebSockets it's a streaming language, streaming protocol. So I have this up running in Workbench. Here it is. I think I showed a little bit how you drop the jar file in from the GitHub repository. This guy right here, you just download it. You could just go like this, just hit the download button. And then Niagara people kind of know just what to do with these things. You drop it in a folder, you restart this Workbench tool, and then you can pull it out of the palette. You just search for it, and then there's a Bask Stream service. And then you just drop it right into the services, and it's worked pretty good just out of the box. But I still want to get like I built a driver for this for Open-FDD, or I should say, I first started with some Python tools, just playing around with it, and then I kind of handed that off to AI coding agents, and they went nuts on making a driver for Open-FDD. But I'm still like need to get a little bit familiar with WebSockets. REST API is pretty basic, pretty easy. JSON API. BACnet isn't too bad for building automation people that have been in the BACnet world for quite a while, but WebSockets is kind of a new thing. So, okay, so like where we left off with is I have a BACnet network in my little office here, office environment, and on my test bench, there is a JCI FEC old device that talks BACnet MSTP to a BACnet router. And there's a couple points learned in here. So like what I've been doing is polling this window, this Windows computer, same Windows computer here that I'm recording this YouTube video in, is running the station, the Niagara station here, and I can pull the sensor data. This is real live sensors. And yes, the duct temperature out of my air conditioner right now is 51 degrees. It's freezing. It's a very terrible little HVAC system I have here in this office I rent. Um, and yeah, so let's kind of like play around with some of the Python tools. So I have to keep this video kind of short. I was playing around a little bit with last video with Wireshark, and just like I thought that would be a little bit easier. So like I might do a different approach, because like I was taking a packet capture on this Windows computer. There's just so much data being streamed in the background. Who knows? I thought it was kind of hard to deal with. So like I think I might do just take a packet capture on the Raspberry Pi itself. So you can use a program in Linux called TCP dump. So it can record a packet capture. Um, and I think we should get into this. I need to personally learn um, when it's like tech support level of BACnet stacks and troubleshooting, being able to do basic packet capture analysis, cybersecurity. It's kind of a skill set to know, and I need to learn. And as you can see in the last video, I don't know what the heck I was doing and couldn't figure it out, which turned into about a half an hour's worth of rambling. Um, so I want to just try taking the packet capture here and then doing some. So this is my Windows PC. We're recording this YouTube video right here. Workbench is running the station, and then we'll talk to the Raspberry Pi through WebSockets through here, and then we can record that data with a TCP dump, and then we can download it, then analyze it in Wireshark. But yeah, this is just like a really basic schematic here of nothing's going out to the internet. We're just like two computers right next to each other. So I might just close this. Okay, so oh shoot, I should have not done was let's see if I just go back to GitHub. Not Backpipes 3, but I just have to get back to the Bask stream repository, and I'm just kind of curious to look at some of these tools, Python tools. What's also really cool is there's docs. So you can look at documentation, model context protocol, and there's even like a little web application that you can play around with too. That's supposed to be a Node JavaScript web application that you can kind of play around with. But I kind of like playing around with Python. So this was, hey, we were just looking at this. So I submitted a couple of screenshots here. And okay, so let's play around with some Python. This is how to install these Python packages. Okay, so like we're in here, just an old crappy Raspberry Pi that's too old to use a coding IDE, but you can still play with them. So if I do Python 3, I think, create a virtual environment. I'll still probably always resort to using Python because I think it's like a really easy tool to just play around with. Okay, so we just created a virtual environment. This env is that thing right here. So what'll happen is it'll be all the Python libraries will be loaded in this little folder, and then call that a virtual environment. And then you can just do tab complete env.bin.activate, and it gives you this little thing to show you that it's activated. Then we'll just do a pip install requests WebSocket client and MSG pack. Okay, so let's collecting the Raspberry Pi. They're installing some of the Python libraries for that. Okay, so let's there is 3 Python files right here: a client, API, backstream CLI. So you can run smoke, tree, values, read schedules, and then yeah, just minimal smoke tests is like what I've been calling it. Okay, so like we can also run some Okay, so right now, the Windows computer that we're on right here, like if I open up, uh, come on, sorry, every time everything pops open on a different monitor, and I have so many things open, it's hard to get it back on running. So, okay, so we're in PowerShell right here. Like if I just do a IP config, I just want to check and see that. Okay, so I'm still on 192.168.204.11. So this is the same computer that's running the Niagara station. And then we can run a command. So we can run this from Linux, and we can make sure that this would be the workbench. The Niagara runs a web application behind the scenes, and we can check. Let's try this command in Linux. So this is like this is bash. We're gonna curl it. Okay, so like when we on the Raspberry Pi, we did a network request called curl from the Linux operating system. PowerShell and Windows has something equivalent to, where you can do network requests from the operating system. And it found that route at Niagara, so that's good. I have to get more familiar with some of this. I'm gonna see what this nc command. I'm not really sure what nc is. Not found. I can't remember what nc is. We'll skip that one. Okay, like the PowerShell equivalent is curl.exe. Ord route quoting. Niagara ords commonly have these goofy things. People that are familiar with Niagara framework, if we all know that, looking at this really confusing dollar signs and a 20 or a 2D is like a space character. So it looks like PowerShell. Must have been when I was testing it. Didn't like double quotes. Sometimes you need single quotes. Single quotes for Linux and Mac. Okay, so let's try this. So this is the backstream CLI. Let's where were we? So let's just go to this one. I'm just gonna copy the name of this. I'm gonna try and cheat a little bit, and then just do a. You can use touch to make a file in Linux. Then I can just copy the contents. Let's see here, copy button. Okay, so now that I have the virtual environments open, need to have the virtual environment running, and I should be able to just do, let's go back to this window. Scroll down, where were we? Okay, so like we could put some environmental variables in there. Let me think. How can maybe I need a notepad or something. Shoot, let me think about this for a second, guys. Okay, so like if I just bring up a notepad here, I'm just gonna copy this. So this should be the credentials in Workbench for. Okay, so hopefully you guys can see this. So in Workbench here, if you were to go, I'm gonna Control tab, open up a new tab to the, let's see, user service. I basically just duplicated the admin account and created an Open-FDD account where that's these passwords. So I should be able to just go like this, pop that in there. Okay, so then these will be, I'm gonna drop these into Bash, and then these are environmental variables. So they're like variables that the operating system can see until you reboot. Then they'll kind of pooged. They'll be deleted, but they're just like temporary variables in memory. Okay, so I'm gonna close PowerShell, then go back to Linux and the Raspberry Pi. I'm gonna drop these in. So these will be just saved variables in memory for the operating system for the login, and then I should be able to use see if this works. There's my run command. No, why didn't that work? Okay, so module not found. Backstream client. Oh, shoot. I guess these files might have been made to run as kind of like a little Python package. I guess we need this one too. So this must just be helper code. Touch. I'm gonna make this Py file too. Just copy the contents. Client. All right, so let's try it out. Module not found. MSG pack. Thought we did this already. Gonna go back up to pip. Oh, that never ran. They were on multiple lines. Okay, so there was another Python tools. Sorry, jumping around a lot here, guys. I need to download this one too. When I did this command earlier, these were on multiple separate lines. Apparently it didn't like that. I thought it disinstalled everything. Try this. No. Oh, okay, so looks like I have to add in my password again. Maybe we can fix that. Oh, there we go. Okay. Got some data. So it looks like it's just testing the API against the station. Stream health was not 200 after Niagara login. Let's try that again. Oh shoot, I know what we did. So I might just get rid of these arguments here. I think the script has arguments, but okay, so dash user, so I'm looking at these arguments here. Try Open-FDD, and then password. This is the same login in the JACE. Okay, it looks like we needed a command. What was the command? Health. Let's try health. All right, looked like it liked that. Okay, cool. So this returned, I think, what we expected here. So basically this returned, I can tell it's like the same data that's in the service on here. If I would go to the backstream service and workbench, it's this. So this would be interesting. This is getting out of my wheelhouse. So max connection. So maybe 10 devices can talk to it. Max subscriptions per client. Wow. Heartbeat interval seconds. Subscription lease seconds. So 5 minutes, I guess. 300 seconds. COV Windows milliseconds. Change on value batch Windows seconds. Wow. So let's just try changing some of the stuff. Let's just try changing that to 333, 33, just for playing around with it. So instead of 30, this is 33, and then 333. And you can see, we can see that we got that data back into Python from on the Raspberry Pi. So pretty cool. Man, there's just so much to go over here. So let's just, I have to actually wrap up for the day here pretty soon, but I'll probably be going back here tomorrow. This is our old mini calendar, schedule calendar device. We could probably just go to that, and we're just going to be playing around with WebSockets for a while. I want to also create a little Python web app right here, and then we can play around with recording packet captures again with just RESTful API, TCP stuff. And then also try recording TCP dump, another packet capture. Just to, for me, it's just getting familiar with using Wireshark. So yeah, I'm sure like a lot of the networking people, the networking engineers, they're probably laughing, but I'm just trying to get used to some of the stuff. And for us building automation guys, this is like people that do Wireshark, that's like tech support level. So it's good for us to, I only use the tool about once every 5 years, and just to keep brushing up. So let's just kind of look at some of the source code in Python, and then I have to call it a day, and then we'll go back at this tomorrow. Okay, so we have a method right here, a function that says read schedule, a read, so this must be a point, and then this is a search. Oh yeah, looks kind of familiar. We just saw that JSON data. Browse capabilities, ping. So this is kind of cool. This is just some really basic. It's a client tool. So like there's server and client, and then I made this code with ChatGPT. Made it actually. So it made a Python web app, WebSockets client. So client requests, server responds. So we just have client in Python, Java responds from the Niagara framework. So yeah, it's interesting. You close your connection because something you must have to do manually in WebSockets. This might be really fun to maybe play around with sockets. There's actually a coding, not a coding, but just like very, very basic way to transfer data is just through sockets. So it should be kind of fun maybe to play around with that too. Wow. So yeah, some of this, a post request. I know that this works with encrypted WebSockets and unencrypted. Before, like when we were playing around with the Wireshark packet capture, it was encrypted. So I think that was a huge reason why I couldn't struggle with trying to see any of the data, because it was encrypted. So this this station here is actually not encrypted. So I actually restarted it on a non-encrypted station on purpose just to play around with this. And I think that you can go into the web services. Yeah, I did change this here to not be TCP, TLS encrypted. So I just want to play around with unencrypted on a test bench. But you're probably better off if it's running in the wild to encrypt it. So yeah, that's the client. So we made the ChatGPT made that. Yeah, getting into bits and bytes on the wire, pretty cool. Simple cookie jar, tiny cookie jar that mirrors the BACnet node helper behavior. Huh. Cool. And then this is the libraries in the Python code here. And then here's this CLI one. Wow, there's just a lot of cool. We'll have to play around with this because there's a way to. I want to build out the tree in the Niagara framework, and then add it into Open-FDD in time. But it's a work in progress. There's a lot to learn. So 600 lines of code here. I have to get going for the day in just a minute. But yeah, discover schedules, discover points. Then you can walk the tree. Yeah, walk the tree right there. So yeah, pretty neat. This almost reminds me of like if you would play around with the BACnet stack in C. It's really hard. It's just all a zillion little functions like this. Cool. Yeah, so let's maybe play around with this tomorrow, and then maybe we can get to the point of this is the tree, so we're going to try and walk the tree here, and maybe build out some better tools of like there's just so much under the hood in Niagara, tons of data. If you actually go and you start discovering everything in here, and you only need 4 little points of real sensors, you're just enamored by the amount of information here that's under the hood in Niagara. So let's kind of play around with that in the next couple days. I have a feeling this will probably take me a couple days just to play around with this. And then we can get into playing around with the Rust BACnet stack. So that's coming. Hope you guys are liking this stuff. And anyone that just wants to, get started with some of this stuff, if you want to join a Discord channel, go to the Open-FDD, or it's also on the Python BACnet 6 playground. Just go here, hit the Discord channel. There's lots of friendly faces on there. So the person that made the BACnet module is on there. Justin's on here. A whole bunch of people like. So there's the AI chat, BACnet protocols chat, Niagara framework, HVAC, and mechanical chat, which would be like fault detection equations, mechanical stuff. Embedded systems, which I want to get into in general. Software engineering chat is also something that it lets web applications and that whole stuff. So yeah, I will see you guys tomorrow. Hope you're having a good one.